If you agreed with me in the first video that the reasons of why you should use JavaScript are powerful, then the next question is, what exactly is JavaScript? I know we understand it's a programming language, but before we move any further, let's make sure we know exactly what it is and what it isn't. So JavaScript is a programming language. It's a series of characters that compile down eventually into computer-readable machine code and make stuff happen. This applies in browsers, but it also applies to handheld devices, Internet of Things, objects, all sorts of stuff. JavaScript is the language and the only language that is supported by default in all major browsers. This is an extremely important feature of JavaScript, as we'll learn. The reason why we're sitting here learning JavaScript today is largely because of this fact. And JavaScript as a language is flexible. It is dynamically typed. So JavaScript is very much unlike a language like Java, which is static typed and must be precompiled. Many people prefer to work in dynamic languages. Me, I prefer them both. Dynamic, typed, they're both good. But JavaScript is a dynamic language by its nature. Briefly, just so that we can understand where JavaScript is now and what its history is, it was created in 10 days by a man named Brendan Eich, and 10 days is not very long for preparing a programming language. This is often cited in the community as a reason why JavaScript isn't so great. Considering he made it in 10 days, JavaScript's a pretty amazing language. But if you wonder why it has its idiosyncrasies, this is one of the reasons. It was designed in just 10 days. Shortly after, Microsoft, for its Internet Explorer browser, created a clone of this script called JScript, which worked pretty much the same way. But since it was a copy, it had a few small quirks. Hence, the many quirks that exist in Internet Explorer today, i.e. 7, i.e. 8, modern Internet Explorer has gotten good with catching up to the standards. So shortly after Netscape and Microsoft both had their own version, it was standardized into something called an ECMAScript specification. So ECMAScript basically means JavaScript, but since Java is copyright and the word JavaScript kind of sort of belongs to Netscape, they just invented the word ECMAScript to stay completely clear of any of these problems. Lastly, in this part of JavaScript's history, we must note that it was designed for small apps, small interactivity. Click here, a button appears. Click here, go to this page. JavaScript was not designed for building colossal single-page apps like Twitter or Facebook, many of which are written with a lot of JavaScript, naturally. The following is a quote from Douglas Crockford. When Java applets failed, JavaScript became the language of the web by default. JavaScript's popularity is almost completely independent of its qualities as a programming language. This is from the book JavaScript: The Good Parts, conveniently available from O'Reilly. I really like this quote because it tells us the most important thing we need to know about JavaScript. People don't use JavaScript all the time because it's great. If you look for greatness in JavaScript, you may be disappointed. However, JavaScript does have lots of ubiquity. It's everywhere. It's the language of default. So jumping forward to modern times, as I mentioned, ECMAScript standard is going to change from ES5 or ECMAScript 5, which it has been for many, many years, to ES6 sometime in 2015, 2016, maybe 2017. Around those years, there is no hard and set time because of the dynamic and flexible nature of the internet. ES6 has tons of new features. If you're a more experienced JavaScript developer, you'll know of these features and will be very excited to be able to use them in the browser. Even today, many, many years after its inception, JavaScript continues to be a dynamic and changing language. And today, if you go to check out the servers of a big box company like PayPal or Facebook, you wouldn't be surprised if you saw they were running a lot of Node.js, which is a backend that uses JavaScript. No need to code in Java or in C for your backend any longer, but we'll learn all about that in a later video. Last but not least, you can do, well, everything with JavaScript. Automate your home, pilot aircraft, create intelligent robots. You can do all of it with JavaScript. In fact, the potential is unlimited. We will be visiting all these topics in later videos, so I encourage you to stick with us. Though, in the modern day, we can find JavaScript on everything from helicopters to your Xbox, JavaScript's main and most important place still lies on the web. In this video, we'll be taking an overview of what we're going to cover in great detail on the chapter on JavaScript on the web. This will also be our biggest chapter, as it is JavaScript's most primary use today, though by no means the least. So as we've learned, and as is sort of becoming the catchphrase of this course, JavaScript is the only language supported by default in all the browsers. I'm repeating this because it's very important to understand. It may be the only important thing about JavaScript to understand, and it helps as well if you're frustrated about learning JavaScript, say for a job. It's not your boss who's making you learn JavaScript. They have no choice. It is the language of the internet. So JavaScript is everywhere, and it's required to do almost anything. True, you can submit a form, you could do anything really, sign up, login, using just HTML, what you would call post requests and get requests, but this is what you would call extremely basic interactivity. In fact, JavaScript is so required that many browsers, such as Chrome, Firefox, and Safari, have either removed the option to disable JavaScript or are moving steadily in that direction today. In other words, JavaScript is here to stay on the internet. You may, in your studies, have learned about such things as TypeScript or CoffeeScript, or what you would call a JavaScript precompiler. So let's say with CoffeeScript, the purpose of CoffeeScript is I write it and it has, many would say, a better syntax and more useful features than JavaScript. And then I would use a program like Node and Gulp, which we'll learn about, to compile this from CoffeeScript to JavaScript. Many people grew frustrated with writing code in JavaScript, so they decided they wanted to write it in other languages so they could have better functions, stronger type controls. As you develop, you may decide that while you understand and appreciate JavaScript, you want to write your actual code, do your work in a compiler like TypeScript or CoffeeScript, and then compile down to JavaScript. This is absolutely fine. However, as a practical JavaScript developer, remember that that TypeScript you wrote and CoffeeScript will never make it to the browser. It first must become JavaScript, which is the only language browsers support. When you use the internet, computers network. They talk to each other, and they send each other electronic requests. When my computer sends a request to your computer can choose to respond or not. If it does choose to respond, it must select a response. The logic for deciding what that response is now well within the realm of JavaScript. There is this program called Node.js, and Node.js does this special thing called interacting with your operating system. So creating files, deleting files, using your networking capabilities, it can do pretty much anything that Apache can do or Java can do, but it's written in JavaScript. On top of Node, an important framework often goes called Express, and Express can actually listen to these web requests that I spoke about. When you go to paypal.com and you make an HTTP request asking for their homepage, there's a good chance that it's express.js responding to that using JavaScript logic. And additionally, your backend also communicates with your database. Many databases, such as MongoDB or CouchDB, communicate natively in JavaScript or a dialect of JavaScript. So in a JavaScript-based web server, you're responding to HTTP requests, interacting with the operating system, and communicating with your database all in the same language, JavaScript. We'll be learning in great detail about JavaScript as a web server in future videos. However, just to be sure, let's disambiguate JavaScript as a web server and JavaScript on a website. When you run JavaScript on a website, my computer sends you a JavaScript file, or a server sends you a JavaScript file, which you run. The file might say, alert this statement to whoever is using the browser. However, the server-side JavaScript is the JavaScript that decides what is sent. So Node.js might use JavaScript to decide to send your computer the JavaScript file it needs. Well, it's a little confusing, but the long story short is JavaScript is everywhere. And as you may have begun to figure out, there are certain advantages to using the same language on our backend as we do on our front end. A modern discussion on JavaScript is no longer complete without a thorough discussion of desktop applications that are written in JavaScript. You may be familiar with desktop applications. In fact, you might be viewing this video in one right now. For example, in Google Chrome, which is a desktop application, or iTunes, which is a desktop application. A desktop application is anything that's meant to run on your computer, be it a PC, a Mac, a Linux, anything. There are a variety of different kinds of desktop apps that can be built with JavaScript. For starters, Windows 8, 10, and Windows Phone all support a thing called a Windows app. And a Windows app is written in TypeScript. TypeScript, as we learned, is a JavaScript precompiler. However, it also looks very similar to JavaScript, which a precompiler doesn't necessarily need to do. Now, Windows phones are not as popular as iPhones or Androids, but Microsoft is a huge company, and it's not going anywhere. Learning to program apps for Windows 8 and 10 is probably a valuable thing to do, considering the small size and newness of these markets. However, if writing apps for Windows doesn't satisfy you, you can write cross-platform apps using Adobe Air. Write your app with HTML, CSS, and JavaScript, and then publish it to the desktop in a thin container. As a matter of fact, Brackets, the text editor which I'll be using for certain videos in this course, is actually written with JavaScript. How about that? Doing a tutorial on JavaScript with an editor written in JavaScript, using JavaScript. It's really everywhere in this day and age. For me, and I hope maybe for you too, video game and simulation design is one of the coolest parts about programming. Who doesn't like to make a cool simulation of a plane flying around, or a video game of some exciting adventure? Well, using a program called Unity, you can write not only a video game, but also a serious 3D simulation that is used by large militaries all around the world. You can create any kind of application you can imagine in JavaScript. Now I say and add Steam because with Steam, you can easily share the application you've made in JavaScript with Unity to the whole world. And not only that, but Unity can also export your game written the same JavaScript to platforms like Xbox, PlayStation. You can really output to a great number of platforms. Unity uses something called a monocompiler. Well, actually, it's a process with about 10 or 12 steps. It's non-trivial at all, but they figured out a way to turn your JavaScript into language that works on any platform at all. So using Unity, you can make desktop games that launch in Steam. If you've played a Steam game like Terraria or Closure, these games were possibly written in JavaScript, in Unity. And of course, this can't be a complete list. There's in fact dozens and dozens of what you'd call JavaScript bundlers or JavaScript compilers that turn JavaScript into an exe file. Of course, each of these differ in their opinion of what the best way to turn a JavaScript file into an exe file is. Performance, supporting different operating systems, these are all important concerns. So in this video, we're not going to make any decisions as to which is the best for using JavaScript to make desktop applications, but I wanted you to know you have a lot of options, and you're absolutely not limited to only writing JavaScript for stuff like websites. So far, in these videos, we've learned about using JavaScript on computers. On your desktop, on your tablet, is there anywhere else we can use JavaScript? There absolutely is, as we'll discover in this video. You may be familiar with this new exciting thing called the Internet of Things. Well, maybe if you're viewing this video 10 years from now, you'll think it's this old, boring thing called the Internet of Things, and it's already everywhere, and we all already have nanobots and personal drones. But for the time being, the Internet of Things is this new idea. It's this idea of all these small, interconnected devices sharing data, doing information. The Internet of Things is not a terrifically specific term, but it does imply a lot of small devices communicating with networks. And JavaScript is already making itself a popular player in this field. Why is JavaScript popular on these other devices? It's because JavaScript is just used everywhere. The greatest percentage of developers entering a new field simply is already familiar with JavaScript. So JavaScript can power a lot of small independent devices. For example, drones and robots can be programmed using a library called Johnny5, which we'll visit in a later video. By the way, on the right, that's a video of a drone, or an unmanned aerial vehicle, a UAV. Judging by the age, this UAV is probably not being powered by JavaScript. However, in the modern age, there's nothing stopping you from building your very own drone and programming complex algorithms for it to follow in JavaScript. Libraries like Johnny 5 manage things such as rotor management or actuated limb control that you'd need out of a robot. Additionally, getting a little bit farther from the realm of the science fiction and futuristic flying machine topic, we can also do stuff much closer to home. For example, you may have heard of home automation, or the process of automatically controlling your home's humidity, lighting, temperature, and other factors to save time or maximize on ergonomic factors. The most popular device for hobby home automation is the Raspberry Pi, and it can be programmed using JavaScript. So if you want to automate your home to have all the lights turn off automatically at 9 a.m., you can do so with JavaScript. If that's not JavaScript in the real world, I do not know what is. We won't be discussing too much of these real-world applications because they're quite complex. I could make a whole video series on any one of these topics. However, I wanted you to know because I want you to have the maximum possible number of choices when you decide how you want to apply your JavaScript knowledge. In this video, we'll be taking an overview of the course. Over the past few videos, we've had a quick look at all the topics we're going to be covering. However, now we're going to list them all succinctly in one place so you can decide if this course contains materials that are valuable for you. We'll also be covering what this course does not cover, which considering what a large topic JavaScript is a lot of stuff. So we'll be covering a variety of topics. We'll learn how to author a website in a modern way, what tools to use, how to test it. We'll learn about effective workflows for writing JavaScript. We talked about precompilers, right? Well, you don't want to manually be compiling your precompiler every time. There are tools written for this in JavaScript that we'll learn to use to improve our JavaScript and our web development workflows. We'll learn how to debug JavaScript using free tools. If you take nothing else from this video series, this knowledge will help you in writing JavaScript of every kind, especially the practical kind. Additionally, I want you to understand the most important JavaScript libraries, libraries like Angular, jQuery. We're not going to be learning the full specifications of these libraries. However, we will discuss what they do, how to use them, and when to use them. So you can make the decision when the time comes, hey, it's time for me to learn Angular. I'm going to pick up the appropriate Angular course or tutorial, or maybe I'm just going to jump right into it. That's for you to decide, but I'm hoping we'll be able to facilitate that in these videos. In addition, we're also going to be covering the using of JavaScript as a web server. We're going to be looking at companies like PayPal who use JavaScript as their web server, and we're also going to write up our own JavaScript web server inside our text editor and give it a shot. I want to mention now that this is not a technical course. I have designed this course to cover mostly ideas about JavaScript. However, from time to time, it will be advantageous for us to write code. Even if you do not understand JavaScript yet, you will still be able to code along with me by simply copying what I type in. If you do understand JavaScript, you'll get a bit more out of it, but you don't need to have any knowledge of JavaScript to get the most from this course. Additionally, we're going to cover package management, which you might say is another way to improve your JavaScript workflow. If you come from a language like Java or Python, you're probably familiar with package management, which is a way of managing dependencies and stuff your apps need. It's quite a discussion, but we're going to both discuss it and do a practical hands-on application of it so you can learn skills that you'll remember for a long time. We're going to learn to automate our workflow, so stuff like minification, copying files, pushing to GitHub. We'll learn that we can do this and should do this automatically using JavaScript, given the opportunity. And finally, we'll drop in to the game and simulation authoring tools that I mentioned. Unity, Flash. We won't be doing the whole tutorial on these programs, but we'll open them up, investigate their JavaScript interfaces, and discuss their strengths and weaknesses, because none of these tools are all strengths or all weaknesses. And last, and in a sense least, here's what we won't be covering in this course, since we can't cover it all. We're not going to learn any JavaScript code semantics. I'm not going to teach you about square bracketed arrays or pointy bracketed objects. This is something that you can learn from a different course. There's countless good materials, or you can sort of learn it as you go along in your JavaScript quest. So we're not going to cover this. We're going to cover the why to use JavaScript and the when to use JavaScript, not the how so much. We're not going to take a detailed overview of everything JavaScript has to offer. We're not going to look at all the number functions, all the array functions. There are excellent tutorials available from this publisher on that very topic, so we're not going to get into it too deeply. In addition, a detailed feature overview would take many, many hours. We won't be covering the JavaScript precompilers, TypeScript, CoffeeScript, even though these are relevant discussions. It's just a whole different domain of knowledge. For now, it suffices to know that once you learn these independently, they'll compile into JavaScript, which is what we're learning now. I regret to say there will be no computer networking discussions or computer science discussions in this course of more or less any variety. When two computers connect, like when you go to Facebook, that is computer networking. And it's important to understand what computer networking is to become a true JavaScript expert. However, you don't need to understand it to become a skilled JavaScript technician. And that is what we're focusing on right now. I do advise you to learn about computer networking from other tutorials or videos if it's something that you are interested in. Knowing computer networking can help you develop, especially for front-end and back-end web. And with that, we now jump into the course. In this series of videos, we're going to be talking about JavaScript in websites. Now, as we know, JavaScript was invented for the web and has almost always existed in websites. Nowadays, as we've learned, you can find JavaScript on backends, even in robots and other places, but its most important place is still in websites. And in this chapter, we're going to discuss its many uses and how you can apply it there. So let's begin by defining what is a website. I know you visit websites every single day. We all do. But as a web developer, it's good to be able to know exactly what it is and not just think it's a big floaty ball of internet stuff that you go to with Chrome. So a website can be loosely thought of as a destination. And you get to that destination by using the HTTP protocol. So when you visit a website, let's say Facebook, your computer sends a bunch of digital signals to a server that sends it to another server that eventually gets to Facebook. Now with Facebook, you're probably going to use HTTPS or secure HTTP, but the basic rules remain the same. So if you set up a website, you set up a program which responds to HTTP requests. Most often, you'll send in response to those requests HTML, CSS, and JavaScript, which will be combined by the browser of the end user to make a coherent website that is informative, attractive, and most importantly, interactive. Back in the day, you would go to the internet and you would say download a document, like some sort of scientific report, and you would read it, and that would be about it. You wouldn't really interact, you wouldn't change the document, or you wouldn't interact with its creator, but this, of course, has changed. Take sites like Facebook, Twitter. Websites are all about interaction. You need to be interactive in websites, and JavaScript is just the tool to do that. So, do you need JavaScript to make websites? Well, HTML is for sending information. Anything that can be said in a sentence, for example, the address of the party is 123 Smith Street, can be sent with HTML. CSS adds style to websites. It makes websites look good. And so while it's not necessary, often you can't omit it without a website being ugly. However, you use JavaScript kind of only for advanced interactivity. You know, a user has to click a link, go somewhere, maybe download something. HTML has you covered for this. But let's say you want them to send a message to another user that's also on your site. Well, you need JavaScript for that. And also, if you want to change the information that's on the page without the user reloading it, then you have to use what's called AJAX, asynchronous JavaScript. So in conclusion, you only need JavaScript for a website that has interactivity. However, it complements CSS and HTML in many ways. For example, the JavaScript library Modernizer will allow you to write better CSS by knowing what CSS features are supported and what are not inside your browser. If you watched that last video, you may have been led to believe that HTML and CSS are more or less all you need to make most websites. It is true that CSS and HTML have a lot covered, but JavaScript does some special things on the web that you need it for, and therefore must learn it. So what can JavaScript do? JavaScript can change information in real time, as we discussed. You can update information on a page without reloading it by using Ajax, a type of JavaScript. Next, if you want the website to remember certain things about the user, like if they're logged in or what their city is, you need to use JavaScript and use a part of JavaScript called cookies. Now, admittedly, cookies are technically part of the HTML API, but you need JavaScript to interact with them unless you're going to use post requests and headers to create them, and that's complicated stuff. Next, JavaScript can do analytics. If you use, say, Site Catalyst or Google Analytics, you're using JavaScript. And analytics, being the eyes and ears of your website, are so important. You simply can't do without them for a major enterprise project. Next, there's many features in HTML and CSS that might work on your PC, but won't work on your iPhone. Lacking the advanced functionality to detect what device you're on, HTML and CSS cannot optimize for this alone. However, using JavaScript, you can dynamically change your website to work on whatever device it finds itself. And to top it all off, you can do many CSS or HTML native things like creating style sheets or creating DOM nodes faster with JavaScript. For example, the JavaScript library react.js uses the JavaScript function setInnerHTML to update the DOM in a much faster way than other conventional methods. The reason why this course is called Practical JavaScript is because it's all about writing the correct JavaScript quickly. You want to write the JavaScript to do the job, and when you're developing JavaScript, there's no better tool than Chrome Developer Tools. Chrome Developer Tools are an absolutely indispensable tool for any JavaScript developer. In fact, as far as any language goes, they're one of the best tools for editing any programming language. They're a big reason why JavaScript has exploded in popularity so soon. But what are they? The Chrome DevTools is an application that lives within Google Chrome. It allows you to debug JavaScript, and you can find similar versions of it in Firefox and Internet Explorer, or IE. They both have their own version of DevTools. However, in this course, we're going to use Chrome DevTools in a demonstration to see exactly how you write JavaScript with them. Here I am inside Google Chrome. I've navigated to the web page about:blank, which just gives me this perfectly empty web page. So we're going to open up DevTools and see what they're all about. To open up your DevTools, go here to the top right, this hamburger menu. Go down to More Tools, and then at the bottom of More Tools, you get these four options. These are all part of Developer Tools. Since we're working on JavaScript, let's jump right to the JavaScript console. Clicking this opens up Developer Tools. As you can see, it's a little window that opens up in Chrome. It has many different options, elements, network sources. I've personally used almost all of these windows to debug one thing or another. However, it could take a whole course to talk about all these features, so we'll stick to the JavaScript console. The JavaScript console is a powerful tool for prototyping JavaScript. Let's do a demonstration. I'll create a simple variable and make it equal to hello world. Now that I've created this, I have greeting in memory in Chrome Developer Tools. If I start to type it, you can see that Chrome auto-completes the word for me. If I press enter, it shows me what it is. Well, that's pretty cool, but can we do more? What if I were to type the word greeting followed by a dot as though I wanted to access a particular method of it? Chrome will automatically create a correct list of all the properties and methods of whatever object that is. In this case, it's a string, so we're seeing all the string methods. If I create a new variable that's a number, and I do the same thing, you can see it has different options. So using Chrome DevTools, we can automatically see all the methods and properties available in whatever variable we have. This is really cool. Finally, you can use the console to debug code by calling the debugger command. Let's try it. If I type debugger, it jumps to my sources panel. Now, this isn't an ideal place to call debugger because we weren't in the middle of an application, so we know all our variables. However, the debugger command will freeze your code right at the moment of execution. Let's see how that works. So we'll stop the debugger by clicking this button, go back to our console, And now we'll define a new function. We'll say function go, and inside this function we'll define a variable. And so this variable will only be accessible inside this function. And then right after that, we'll call debugger. So if I try to access the secret variable in this global scope, secret is not defined. It does not exist. However, if I call go, it will trigger my debugger. Now, inside the console, while I'm debugging, notice I have my drawer open by clicking this item. If I type secret, I get access to my secret. So now I'm within my JavaScript code while I'm debugging it. There are, of course, hundreds of additional features I could talk about in the JavaScript console, but this gives you a good overview of how to access it and how to use its most basic and more advanced features. As a JavaScript developer, you will, on a regular basis, need to actually write or author JavaScript. Is there a right way or a wrong way of doing this? Let's find out. So most of the time, you'll be doing your authoring in an IDE, an integrated development environment. This means that your environment will have a text editor most likely, and it may have a bunch of other features like a file manager or a server running inside of it. Anything that's a text editor with a bit more on top is referred to as an IDE. Your choice of IDE should be based on critical JavaScript-related features that it has. Can it complete JavaScript code? Can it lint or detect errors in code? Can it automate it? And how much does this tool cost? Is it free or is it more expensive than you can afford? When you're working with JavaScript, your browser becomes a part of the IDE, sort of organically. JavaScript has many libraries that will reload your browser automatically, open it automatically. JavaScript is one of the languages where you really take your browser and make it part of your development environment. And as we learned in the last video, when we've written our JavaScript code, we want to make sure it works by using debugger statements wherever we think there may be an error. So in the next video, we're going to see what some of these features mean in a very brief JavaScript authoring demonstration. By the way, I mentioned there were a lot of text editor choices, so just to let you know, a few of the popular ones are Sublime, IntelliJ, and a tool called Brackets, which I'll be using in the next video. There's also a text editor called Atom, which is new, a text editor called TextMate on the Mac, which I've heard is quite good. Really, there are dozens of choices, but that's just a few. Here I am inside my text editor. In this example, I'm using Brackets. Is Brackets the best text editor for editing JavaScript? No, but it is free and open source. So while you may have better luck with an expensive program like JetBrains IntelliJ, in case you cannot afford expensive JavaScript editing software, free software will work just as well, as we'll see with Brackets. Now, an interesting thing with Brackets is it's actually written in JavaScript. It's written in JavaScript, HTML, and CSS and put in a thin shell made by Adobe. But this is mostly academic. So what kind of features do we want in our IDE? Well, I have a demo.js file open. If you'd like to try along at home, open any JavaScript file in Brackets. Let's start by writing some code. Notice how the code on the screen is different colors. The word var is blue because it's a keyword, and the word hello is orange because it's a string. A good text editor will have the technology to automatically highlight your JavaScript syntax in order to make it work better. Next, you can see to the bottom right, I have this little checkbox. This is my JavaScript linter. You can see it says no JS lint problems found. Good job. So this is automatically checking my JavaScript code for errors. If I were to write some JavaScript code which has an error, and I save it, look at my linter. It's turned into an unpleasant exclamation mark. What does that mean? Well, I have a couple of JavaScript errors. Indeed, this JavaScript code wouldn't work at all because bar is not defined and foo is not defined. So what does that even mean? Here I've gotten this warning inside my IDE. It's alerted me that I've made an error before I've even had a chance to run my JavaScript. Whichever IDE you have, make sure it can do this satisfactorily. You'll notice that this program has many of the features of DevTools. If I type my var and then a dot as though I was wanting to access one of its properties, I once again get a list of all the properties it has. the program is able to infer it as a string because of the code on line 1. Now, you should be aware that this code completion does not tend to work nearly as well as in Chrome DevTools. Chrome DevTools is always kind of 100% right. It's really good. This is kind of just a way to help you move a bit faster. It may not have all the methods, or some of the methods may be wrong. It may even incorrectly infer your object type, but this feature exists. Finally, depending on what IDE you have, it may have many other features that help you integrate. It may automatically be able to run your gulp code, or it may be automatically able to compile your TypeScript. Brackets is fully extensible. You can download plugins to add new functionality. Here, the only plugin I kind of like is my old Git Bash terminal. I've installed this plugin, so if I click this, it opens up a command line terminal that I can run JavaScript in. This is also kind of part of my IDE. Even though it's a separate terminal window, Brackets has kind of brought it into the fold by allowing me to open it right in the window. So if you take anything from this video, it's that you shouldn't be editing your JavaScript code in TextEdit or Notepad or WordPad because there are many free and not so free tools to help you do this. Using a good JavaScript development environment will send you leagues ahead of the pack in terms of being a practical JavaScript developer.